Alright, so today I'm gonna be explaining this beautiful paper revisiting heterophily for graph neural networks. This NeurIPS paper in 2022. Graph neural networks extend basic neural network by using graph structures based on relational inductive bias, which is the homophily assumption. While GNNs have been commonly believed to outperform neural networks in real-world tasks, recent work has identified a non-trivial set of datasets where their performance compared to neural networks is not satisfactory. Heterophily has been considered as the main cause of this empirical observation. Numerous works have been put forward to address it. So we first revisit the widely used homophily metrics and point out that their consideration of only graph label consistency is a shortcoming. Then we study heterophily from the perspective of post-aggregation node similarity and define new homophily metrics, which are verified to be advantageous compared to existing ones. Based on this investigation, prove that some harmful cases of heterophily can be effectively addressed by local diversification operation. Then they propose adaptive channel mixing, a framework to adaptively exploit aggregation, diversification, and identity channels node-wisely to extract richer, localized information for diverse node heterophily situations. So their model is called ACM, which is more powerful than the commonly used uni-channel framework for node classification. So these are the metrics of homophily. But considering different relation between node labels and graph structures. So H node is the local homophily value for node. So all of these definitions are based on the linear feature-independent graph label consistency. The inconsistency relation is implied to have a negative effect to the performance of GNNs. You see an example of harmless heterophily. So we first define this post-segregation node similarity, and is just the Gram matrix that measures the similarity to each pair of aggregated node features. So we can put it simply like this. After each gradient descent, we have this update where gamma is the learning rate. So pretty straightforward. The aggregation similarity score is defined like this, which this mean takes the average over U of a given multiset of values or variables, and it measures the proportion of nodes as which the average weights on the set of nodes in the same class is larger than in the other classes. And you see example of how diversification can address harmful heterophily. These are experiments on synthetic graphs. So they propose adaptive channel mixing, which is a 3-channel architecture which can adaptively exploit local node-wise information from aggregation, diversification, and identity channels. So a node V is diversification distinguishable if it has these two conditions. And this is the graph diversification distinguishability value. So the ACM model, it just consists of 3 steps. Feature extraction for each channel, then we do row-wise feature-based weight learning, and we then use node-wise adaptive channel mixing. They compared the visualization using TSNE algorithm, the visualization of output layer of graph convolutional networks and their ACM GCN. They did experiments on Cornell dataset, Texas dataset, Cora, CiteSeer, PubMed. The most difficult datasets here are Chameleon and Squirrel. These two are the most difficult because the measure of heterophily is very high in comparison to other datasets. Cora is almost homophily, then CiteSeer, then PubMed, but the most difficult one is Chameleon and Squirrel.